Hello, everyone. I hope that everyone is doing well and you are staying healthy and safe during this time. This week, we are going to be talking about making inferences about a population. And we're going to do that by using samples. And remember that the sample has to be random in order for it to represent the entire population, to be a valid representation. And so we're going to do this using proportional reasoning and with some ratio tables. So let's start with example 1. Hopefully all of you can see this. So I'm going to read it for you, and then we'll get started. Mrs. Kenny surveyed all of the 24 students in her first period class. 9 said that ice cream is their favorite dessert. If there are 288 students in the 7th grade at Windsor Knolls Middle School, how many can we predict would say ice cream is their favorite dessert? So we have this random sample, and 9 out of the 24 students say that they prefer ice cream. So we're going to make an inference about all of the 7th grade using this information. And so I'm going to set up a ratio table. I'm going to label it first with part and whole. The whole is going to be the total number of students. And then I'm going to fill in this ratio table using the information provided. So how many total students are in my first period class? And that would be 24. And 9 said that ice cream is their favorite. So 9 is the part out of 24 total students. Now, if there are 288 students in the entire 7th grade, so the 288 is going to go down here with the whole. There are 288 total students. And so now, using our knowledge of ratio tables, I should be able to figure out this part. So how do we go from 24 to 288? This is a calculator standard, so you may use your calculator. And I'm going to do 288 divided by 24, which gives me 12. So I have to scale up by 12 to go from 24 to 288. If I do that with 9 as well, I get 108. So 9 over 24 is equivalent to 108 over 288. The last step is that I have to go back and answer the question. How many students can we predict would say ice cream is their favorite dessert? Well, that is the 108. So I'm going to write that in a sentence. 108 students would say that ice cream is their favorite. So I used this sample of 24 students and knew that 9 out of them prefer ice cream to make an inference about the larger population. There are 288 students in my larger population, and using that ratio table, we determined that 108 of these students would say that ice cream is their favorite. Okay. So let's move on. I'm going to scoot it up a little, and we're going to move on to example 2. Talk about some candy. So a random group of students has to be random at Windsor Knolls Middle School was asked about their favorite candy. The results are listed in this table below. If there are 752 students at Windsor Knolls Middle School, How many students can we predict would say that a York peppermint patty is their favorite? So I have some data down here. 9 students prefer Snickers, 5 M&Ms, 7 prefer Starburst, 5 a peppermint patty, and 6 students prefer Twizzlers. So the first thing I'm going to do is determine, well, how many students were surveyed. So I'm going to find the total number of students. How am I going to do that? I'm going to add up the total number, or I'm going to add up these numbers to figure out the total. And if we do that, we get 32 students. So out of those 32 students, I know that 5 say that a York peppermint patty is their favorite. So that is my sample, the 32. So I'm going to do the same thing. Part, whole. 32 students were surveyed, and 5 of them prefer the York peppermint patty. Well, I know my new whole. There are 752 total students at the school. So I'm going to put this on the bottom. So now I have to determine how to go from 32 to 752. And I can use my calculator. 752 divided by 32. And I get 23.5. If I multiply that by 5, I get 117.5. Well, we're looking for the number of students. Does 117.5 make sense? Can we have half of a student? No. So we can say, as our final answer, that approximately 118 students out of 752 students prefer a peppermint patty. Since that's not the exact answer, I'm going to use this approximately sign. Okay, we have one more example. Okay, one year researchers tagged 30 deer. They later captured 15 deer and found that 5 were tagged. How many deer would you expect to be in the woods in total? So we're going to use part, whole again for our ratio table. And the part we're going to say is the number of deer that are tagged. And the whole is the total number of deer. So looking at that first sentence, it says 1 year researchers tagged 80 deer. So I'm going to put the 80 with my label of tagged deer. They later capture 15 deer and found that 5 were tagged. So I'm going to put the 5 with the part. 5 out of how many? How many were captured? 15. So I'm going to put the 15 with the total. So now I'm looking for this value right here. How many deer would we expect in total in the woods? So I'm going to kind of work backwards now. You could think of this one of two ways. How could we go from 80 to 5? The value's getting smaller, so we're going to divide probably. Or how could we go from 5 to 80? I'm going to think of it like that. 5 times what will give us 80? So I'm going to do 80 divided by 5. And I get 16. So I have to multiply 5 by 16. Kind of working this way. So what is 15 times 16? 240. So we could expect, we could infer, we could predict that there were 240 deer in the woods. Another way you could think about this is comparing the number of tagged deer to the total. Well, I can easily go from 5 to 15. 5 times 3 is 15. So 1/3 of the total number of deer captured were tagged. 1/3 of 15 is 5. So if I do the same thing over here, 80 times 3, that also gives me the 240. So we could expect that there are 240 total deer in the woods. Remember that we have to write our final answer in a sentence to answer the question. So please let us know if you have any questions about this. You can send an email or a message in Schoology, and we will do our best to answer. Bye, guys. Take care.